Hey there everybody, Robert Taylor with Wonderscape Creations, continue on with another world building series within the PCG line of thinking. So, something that I realized that may have left you guys stumbled because you may still only be seeing one visually, but still have a whole bunch of these. Here in the data asset, I went ahead and with all of my indexes, I have different seeds. So there's 1886 right there. That was an accident. 12641. And then you got 148,941. So I just changed them all. I intentionally set up everything so that I had something to work with to show you guys. And I need to make sure I make a habit of pointing that out to you guys each time. That way you know what to expect. Just so you're aware of what my 7 are. We got large boulders, we have large trees, we have boulders, and trees, large rocks, shrubs, and clutter. So that's everything we're going to be working with there. Now, as far as this goes, there's going to be one other thing we do before we work with getting everything attached to the landscape directly. And in order to best do that, so that we can easily see how it works, is we are going to mess with the spline points a bit here. So let me generate us a whole bunch of them. There we go. So we have a whole bunch of points. And yes, they disappeared. And that's fine. We just need to come back in over here. There we go. And now we have a crap ton of points. Now then, just so we can easily see them all. That's what happens when you move the spline. All of these many points. So we are going to be making another subgraph. And this subgraph is going to find the distance from the edges to the center and help us to keep everything uniform. Because we're going to have a transition that's going to thin out these all these squares depending on how close they are to the edge. And unless you want that transition to always be growing with the spline, we need to do some maths and whatnots to make sure that it stays at a specific distance. So let's go ahead first and make our new subgraph. And it's also important to note, you don't have to make subgraphs if you don't want to. Unless it's a loop. So if you want to do all of this right here in the assign data one, you can go ahead and do that. But to make it easier to read, I intentionally do that. So let's go ahead here. I'm gonna right click, type PCG to get a graph. I'm gonna do PCG underscore create Falloff TLCOA. All right. Now we're going to open it up. And the first thing we're going to do is we are going to create some parameters. Now, you don't have to do it this way. You can do it the way that I did with this, to have a whole bunch of these right here like this if you want to. But I want to make sure everyone's aware of this little feature here. So I'm going to do it this way. So when you have graph settings selected, you have parameters here. And if you hit the plus sign, you get a new property. Now, To rename it, obviously hit the down arrow. You can rename it. You can change its type. These are all floats, so we don't have to worry about doing any of that. We just call this one biome Falloff. Rename biome Falloff distance. Biome Falloff density. There we go. And now when we do that, if we right click, we can do get biome, and look at that. We now have this yellow handy dandy feature right here. Now then, just so that we can easily see it for now, I'm going to do settings that are similar to what's right here, which interestingly enough, I did not set. 1 second. So the layer transition, we want to point to biome Falloff. I need to fix this. You need to go up there. Compile, save. We'll change them right here. Point 2. I am in the primary data asset blueprint. The biome Falloff we have as 0.8. And I locked these from 0.001 to 1, 0.001 to 1. Now the reason I'm doing this is because we're going to be doing some dividing. And dividing by 0 is a huge no-no, a massive no-no. So we're going to make sure that doesn't accidentally happen. And then the biome Falloff distance, I'm going to put to 5,000. And then this one as well has a locking. I think I locked it between 0 and 1. Because I don't think I divide here. If we do, we'll change it. And the density I put at 0.5. All right. Compile, save. There. Now we have them there. So, sorry about that. Back to what I was doing. So for biome Falloff, instead of the 0.8, I will make it 0.5. And then the distance, I'll do 3,000. And the density, I'll put 0.5. And I'm doing this so that we can easily see it working once we plug in the data from the data asset. All right. So the first thing we're going to want to do is in the input here, we just want it to be point data. Point data. We'll make it required to have this in there. Obviously, I'm not going to do a bool transition, but we will be doing that for the height so that you'll know how to do it if you want to choose when this type of transition happens. So let's go ahead, and first thing we want to do is right click and get spline data. Because now we are going to get the spline sampler. And the reason we want the spline sampler is so that we know where the edges are. So in here, from mode, we're going to change it to distance. And I think that's all we'll need. If we need to change anything else, we will down the road. Then we're going to pull out of the input node and type in the word distance. So obviously we need the source. The source is everything, but what is the target? So the target is the spline sampler. And within the distance node here, the only real thing we're going to change here is center and center. I just find that I like the source shape better this way. You can choose whichever one you want. We're going to pull out of here, right click, get biome fall off distance, and that one will go in the maximum distance. Right there. And we can minimize that. And that's all we need from there. Now, if we were to... we don't need that for now. Let's go ahead and attach this so you can see how this works. We can go back into the assigned data, which is where we're putting it. Save everything here. Drag this out, the create Falloff PCG graph. We're going to create a subgraph node. We don't need a loop node. Do this. Oh, right. Transform points. Now, you don't need the transform point. Interesting. Output, yeah. Oh, right. We need to set density. There we go. Look at that. So now, everything within a set range is going to be going from black to white. So we change this to 5,000. Obviously, it's a bit more on the crazy side. Oh, I did 50,000. There we go. Transitioned in a bit. So that is literally what we are doing here. I'm going to change this back to 3,000. All right. So we need this information. And the reason we need this information is so that we can create the fall off and the density. So let's go ahead and do that. So for now, pull that out of the way. We don't need it. You can delete it if you don't want it. I'm just doing it so that we can see what is going on. So I'm going to pull out of the distance node and type density filter. Now, the density filter, this, as you can see, has removed everything that's black. So we can control that. Go to 0, brings it back. Go to 1, completely removes everything that isn't white. And it is highly important to understand how all this works. So this takes whatever you are transitioning. So for this, it's the density with the distance. So it's doing that. You'll see me use this node a few other places, showing how it actually utilizes, because this changes based off of black to white, nothing else. So it makes it super duper easy once you understand how it works. So what we are going to do here is we're going to go to this drop down here, and biome fallout goes into the upper bounds. And I have the lower bounds set to 0. That way, all we have are these numbers. Then I'm going to copy and paste this density filter, place it in here. And then this one right here will also be utilizing this fall off, but we'll be doing some math. So first we need a subtract node. And then we need a, divide node. Sorry, I need some more space. Oh, come on. There we go. Is that right there? Now then here, this will go right here, and we will type create attribute simply so that we can make this a float and put the number 2 on here. So this is the only controlled hard-coded value in here. And that's because I had to artificially create what used to be unintentionally simple, I guess is the word I'll use. So we'll put this in upper bounds. In older versions. All right. So now, if I hit D, we won't see any difference, but if I hit D here, so this one down here at the bottom gets everything that's nearly black, where this one gets black and gray. So hallelujah there. So next we need to do get a difference node, and we're going to change it to binary and discrete. Don't ask me what the difference is, it just is. And we put those in here. So now we only have the gray. So we only have the gray and the black. I now have them separated. So this is what we needed for the distance to determine all that. So I'm going to highlight all of it, hit the C button, and type distance. Okay. Next, we are going to get what's called an attribute noise filter. Well, it's not a filter. Well, anyways, place that in here, just like that. And we want this to be, and the input source to be the density. Then everything else is good. And we need another density filter. Place that in here. So now, if we do this, here, that's why. So as you can see, if I go 0.1, okay, there's nothing 0.1 about it. Oh, right. So this one, we go with 0. And then if I go to 0.5, it'll stay the same. 0.4, there we go. 0.3, 0.2, that's all gone. Now, obviously, there would be a 0.1 and everything between 0.0 and 0.1 if the transition was large enough. So let's put that at 0.5. So we are now going to pull down this drop down and get the biome Falloff density. We'll go ahead and plug that into upper bounds. And then do exactly what we did here. With this one. So copy, paste. You will go straight from this one. That's right, that's not needed. There we go. And then we'll put you here in the, oh, that's why it's doing that. Grab one of these, paste, place you there and you there. You go into upper bounds. there we go. So as you can see, the black is far more sparse than the gray. And that was done because of math. So it's taking this number, dividing by 2, and subtracting that. That's literally all I'm doing to create this seamless transition. Seamless transition, not seamless. So now, whoops, to highlight all this stuff, click C, noise to density. We are almost done. So now, let's pull this out here because we're going to need it in a moment. That can definitely be deleted now. We're going to pull out of here and get ourselves another difference node. Obviously binary and discrete. And the difference node, just like it did here, where it's subtracting this from this, we're going to do that here. And the beautiful thing is the differences can take multiple connections. And now we attach it to the out. Hit save. You go ahead and hit D right there. Come back out in here. There we go. So we've got this lovely transition. Now let's go ahead and get those attached. Alrighty. So let's go into the graph settings. 1, 2, 3. We're going to 4 this time. Rename this one to biome Falloff. Rename to biome Falloff distance. Rename to biome Falloff density. And then, because I want to come back later, this one will be a bool. Rename to debug. All right. So now that we have that, go back to the main graph. We go down, you'll see we have these right here. So we are now going to grab those specifically. Make this bigger real quick. Copy and paste. Just because we need 3 of them for now. We'll worry about debug when we get to debug. Here we go. This one will be biome Falloff. Copy distance. Okay, what did I name it? Oh. Forgot an F. Compile, save. So it's still going to show as an issue. It's fine. There we go. Then fall off density. There we go. Now we're going to put the fall off into the fall off, distance into distance, density into density. Again, you could easily do these the same way that we did it here with this, but I'm trying to put into, everyone's brains, have it drive into home, that there's multiple ways to get the information into a graph. So now that we have those in there, we can come over here and just save everything real quick. And then I'm going to choose biome. Oh, rename. That's there we go. Biome Falloff. Biome Falloff distance. Biome Falloff density. So we've got these all right here. Now then, let's go ahead and make this smaller so that you guys can see it happen in real time. Look at that. Density didn't do any changing. Let's find out why. Okay, 1 second. All right, so yeah, we need to go back into this. Come here to density. We want to change this to 0.001 to 0.5. 0.001 to 0.5 on the biome falloff density. This will lock it into place. Yeah, come down here, do this. It'll be even easier if we do just like that. And because we have so many points, it's a little ridiculous. So it is thinning out, I swear. But there we go. We now have everything. And as I said, as we get through a bunch of this, it will look a whole lot better. You know what? Let's have some fun here real quick. Be right back before we end this. All right, as you can see, I thinned out everything, and now you can definitely see a quick transition. I say quick, but it's not. A transition from thick to thinning forest, or biome, essentially. One thing that I did miss from my notes here in the create fall off, these last two density filters, they're supposed to be inverted, and I did not do that. So I apologize for that, but now we have it working. So if I come over here and I change this to 0.5, 1. So you can see that there's a huge change. And then if I come over here to the biome, this one right here, and I go to 0.1, 0.2, look at that. Nice and clean. So yeah, that is the transition. So in the next episode, we will get everything projected onto the landscape, as well as gets to the creating the slopes, so that it's not showing up where we don't want it. Thank you guys so much for watching, and I'll see you in the next episode.